Very good morning, children. Today again we are starting that we are continuing that our online classes. In the last classes also we have discussed about these polynomials. With the help of the video, some of the concepts you have learned from there. That is, what do you mean by the polynomial? And what is the degree of the polynomial? What is the zero of the polynomial? And also the types of the polynomials as a linear, quadratic and cubic polynomials. And also these polynomials will be with one variable or with two variables and three variables. All that the small concepts we have learnt with the help of the videos what we have sent. And the next important concept in this is the remainder theorem. The remainder theorem means we are able to find that remainder without that actual division, but that is applicable only for division by a linear polynomial. Just we have to go through this remainder theorem. P of x be any polynomial of degree greater than or equal to 1 and let a be any real number if P of x divided by a linear polynomial, that is x minus a, then the remainder is P of a. Means in the place of x we have to substitute that a. Whatever that last answer you are getting is the remainder. So that proof just we are going to do this. How it is? Now let Px is any polynomial which is divided by x minus a, which is a linear polynomial. Then some quotient will be get. Let the quotient is q of x. And also there will be some remainder. That remainder we can take as a r of x. Already you know that division algorithm, that is p of x is equal to x minus a into q of x plus r of x, means dividend is equal to divisor into quotient plus remainder. So here this is the divisor x minus a into quotient the q of x. Here that r of x we can write it as a r only. Why? Because it is we are dividing with the linear polynomial. So remainder degree, the degree of the remainder must be less than the degree of the divisor. Since the divisor is the linear polynomial and having that degree is the 1, the degree of the remainder must be less than 1, that is the 0. So we can write it as r of x to the power of 0. X to the power of 0 is the 1. 1 into r is the r. That is why we are writing it as p of x is equal to x minus a into q of x in plus r. Now we have to substitute that x is equal to a. Then p of a is equal to a minus a into q of a plus r. A minus a is the 0 into q of a plus r. 0 into q of a is the 0. 0 plus r is the r, which is a remainder. So this is the way to find out the remainder when we are dividing a polynomial with the linear polynomial. This cannot be applicable for even for quadratic or the cubic polynomials. The dividend must be any polynomial, either quadratic or cubic or biquadratic or with any power. But the divisor must be only with the linear polynomial. Okay. Now we can take that one of the example which is based on this is find the remainder. Find the remainder when p of x is equal to x to the power of 4 plus x cube plus minus 2x square plus x plus 1 plus x plus 1. So this is the polynomial of the degree 4. I said that dividend must be any polynomial with any degree. So here it is, p of x is equal to x to the power of 4 plus x cube minus 2x square plus x plus 1. Now this we can divide it by x plus 5. You can take any linear polynomial. Now we can do this. Division, actual division, how much time it will be take and how much time it will be take to find out the remainder by using the remainder theorem. Now x to the power of 4 plus x cube minus 2x square plus x plus 1 divided by x plus 5. Already you know that how to divide the polynomials. Now here the x to the power of 4 is there, here the x is there in the divisor. We have to get that x to the power of 4, we have to multiply x cube. X cube into x to the power of 4, x cube into 5 plus 5x cube. Okay. Now minus, this is cancelled, plus x cube minus 5x cube minus 4x cube minus 2x square. Now again here x plus 5, here that minus 4x cube. X should be multiplied with the x square, 4x square to get this one. So we have to multiply here minus 4x square. Minus 4x square into x minus 4x cube. Minus 4x square into 5 minus 20x square. Now plus, and it is the plus, cancel it. Minus 2x square plus 20x square plus 18x square plus x we are taking down. So how many times it will be go from here? That is 18x square, here is the x. So how much time, how many times we have to take? Plus 18x. So 18x square plus 18x into 5, 90x. It is a minus, cancel it. Minus 89x plus 1. Okay. Minus 89x. Minus 89x plus 1. How many times it will be goes? Minus 89 times. Minus 89x minus 89 into 5. 89 into 5, how much? 5 9 is a 45, 8 5 is a 40, 44, 444, 445, 445. Plus and plus, cancel it. So how much you got? 446 is the remainder. Okay. Now this is taken this much of the time. And the same problem, we have to use that remainder theorem and we can find out the remainder. Now here this I am repeating of. Now see here, p of x is equal to x to the power of 4 plus x cube minus 2x square plus x plus 1 and divided by with what? Divided by x plus 5. This you can write it as divided by x plus 5. Should write it as x minus 5. Why? Because that should be in the form of that our theorem, x minus a. So that in the place of x, that's in the place of a, what is there? Minus 5. So substitute that a is equal to minus 5. You can substitute here is equal to p of minus 5 is equal to minus 5 whole to the power of 4 plus minus 5 whole to the power of 3 minus 2 into minus 5 whole square plus minus 5 plus 1. Now we have to simplify it. Minus 5 whole to the power of 4. Since the power is 4, even number, so that will be a positive, 625. Minus 5 whole to the power of 3, that is equal to minus 125. Minus. Why? Because minus 5 whole square, that will become the plus 5 whole, plus 25. Plus 25 into 2, how much? Minus 50. Minus 5 plus 1. Now we can take here, simplify. 625 plus 1, 626 minus, how much? 125 minus 50 minus 5. How much? 125, 175, 180 minus 180 is equal to 446. Your remainder is 446. Did you see that how easily we can find out the remainder? So this is the method can be applied. Again, once again I am telling, this method can be, or this theorem can be applicable only for the division of a polynomial with any degree divided by only the linear polynomial. In case if he gives that a divisor in the quadratic polynomial, we have to divide into the two factors which are the linear polynomials, and then you have to apply this theorem. Okay, this is one example for you. Are you understood, please? Put a glance over it. And I'll give that one more problem to you. Find the remainder when p of x is equal to x to the power of 4 minus x cube plus x square minus x plus 1 by divided by x plus 1 we can take. It is the fourth degree polynomial. It is the first degree polynomial. It's need not to be only the fourth degree, at any degree. Now x plus 1 should be right in the form of the linear polynomial which is divided by this. So x minus minus 1. So in the place of a we should write the minus 1. Now you can write here the p of x is equal to x to the power of 4 minus x cube plus x square minus x plus 1. Remainder is p of a, or that means p of minus 1 is equal to minus 1 whole to the power of 4 minus 1 minus 1 whole cube plus minus 1 whole square minus 1 plus 1. Check it again. X to the power of 4 minus 1 whole to the power of 4 minus x cube minus 1 whole cube plus minus 1 whole square minus of minus 1 plus 1. Okay, now is equal to minus 1 whole to the power of 4 is the 1 minus 1 whole to the power of 3 is the minus 1 plus minus 1 whole square is the 1 minus of minus 1 plus 1. Simplify it. 1 minus of minus plus 1 plus 1 minus of minus